Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 14.2, Problem 5. This is Section 14.2, Problem number 5. It says the Yodeling Mannies of Fall River is a local club that is planning a fundraiser. They will be holding a car wash in the parking lot of Shaw's Market on Columbia Street in Fall River. Based on experience from previous car washes, they know that if they charge $8 per car, they can expect 60 cars to wash. In the latest issue of Everything Tastes Better with Charisse magazine, there was an article that said, when you have a car wash in Shaw's parking lot, for every 50-cent discount you offer, you can expect 5 additional cars that will want to be washed. So Part A says, find a function that determines the revenue based on the number of 50-cent discounts given on the original $8 starting price. So basically, the revenue equals the cost per car times the number of cars. So what they had been doing is the cost per car was $8 and the number of cars was 60. So at $8 a car for 60 cars, it generated a revenue of $480. And they want to make a little bit more. So if every discount you give, you get more cars to wash, but you're making less per car, and there's some magic point where you make the most money. So it says for every 50-cent discount on the price, so let's start with $8 minus 0.50 for 50 cents times X, where X is the number of discounts. One discount, so $7.50, 2 discounts, $7, 3 discounts, $6.50. What's going to be the best price? X is the number of discounts of 50 cents each, the 50 cents being half a dollar. And starting with 60 cars to wash at $8, every time they give one discount, they can expect 5 more cars to wash. So X being the number of discounts times 5. So if you go down to one discount, it'd be $7.50, and instead of 60 cars, it'd go up to 65. So that's the revenue function. Now, I can clean that up a little bit. It is the revenue function, but based on the fact that I know I'm going to be working with parts B and C following this, let me just simplify this a little bit. Revenue equals, so what I have here is something that can be FOIL. So I'm going to go 8 times 60 is 480. And then 8 times 0.5x will be 40x. And now negative 0.50 times 30, watch your sign. So negative half x, basically. So half of 60 is 30. So it's going to be minus 30x. This 0.50 x times 60 is negative 30x. And then negative 0.50 times 5x. So half of 5 is 2.5. It's going to be negative. Negative times a positive. So minus 2.5 or 2.5. X, both have an x. It's x squared. And now I can combine my like terms. I have 2 pieces that are both an x. So revenue equals 480. There are no other plain numbers without a variable, so that'll stay. That's done. 40x negative 30x. So I can combine those. Those are both an x to the first. Notice I cannot involve the negative 2.5 because its x is x squared. That's different. But the 40x and negative 30x can be combined for a positive 10x, done. And then minus 2.5x squared. There are no other x squares to combine with that, so it'll just come down, minus 2.5x squared. So now, this is the revenue function that will determine the revenue based on the number of 50-cent discounts that are offered. So that's part A. B says, find the price that will produce the most revenue for the car wash. So I have my revenue function from part A. We want to maximize it. So we're going to take the derivative, set it equal to 0, solve for x like we did with some of the other functions. What's different from this problem and the previous functions is the previous problems, we have to make the function. Up until now, they just gave us the function. Now we have to make it, and this is how we did it. So now, to maximize it, we'll go revenue prime, the derivative of the revenue function, equals, the 480 has no variable, so it's just going to go away. Its derivative is 0. The 10x, its derivative is just 10. Again, when you have something with an x to the first, its derivative is just whatever the number in front of the x is. And then the negative 2.5x squared is going to be minus 5x to the first. Now, where that came from, my exponent of 2 came down times the number in front, negative 2.5. 2 times negative 2.5 is minus 5. X to one less power, that second power drops to a first power. So now that I have the prime, the derivative of the revenue function, the next thing I'm going to do is set it equal to 0. So take my 10 minus 5x and just go 10 minus 5x equals 0. And now solve it. So that's pretty easy to solve. Just take the minus 5x, I'll pull it to the right side of the equals, and I'll have 10 equals 5x. And if you divide out the 5, you'll have 2 equals x. So that's telling me the number of 50-cent discounts that will produce the ideal revenue is 2 discounts of 50 cents. So what that is, if you're starting at $8, if I take 2 discounts of 50 cents, the ideal price that will produce the most revenue is $7. If you charge $7 per car, the additional cars that come in, even though you're making less per car, will give you the most revenue possible. And then that takes us to part C. What is the maximum revenue that can be achieved? So the best price is $7, which came from 2 discounts of 50 cents. Now, if you were starting with 60 cars and you gave 2 discounts, each discount would increase the number of cars by 5. So 1 discount, you'd go up to 65. The second discount, you'd go up to 70. So it's $7 per car. You're going to wash 70 cars. So $7 per car times 70 cars will give you a revenue of $490 instead of the $480 that you were making before. So the most revenue they can make for this car wash is $490.